Okay, in problem set 13.2, we're going to discuss the deconstruction of a triangular prism and answer a few questions about it. So here we go. This is our triangular prism. Suppose we split the prism into pyramids like the ones we built earlier. Now, the ones we built earlier, hopefully you took advantage of the extra credit that was offered in lesson 5.12. Because building those pyramids is a good representation of what we have here. Okay, so here's what we're going to do is we're going to slice through these points, E, D, and C, and the remaining part of the prism is sliced through B, C, and D. And when we do that, we create these pyramids. Okay, so using the pyramids that we built, compare pyramids P1 and P3. So if we think about it, pyramid P1 can be this pyramid, and this face on the top was P1, and P3 is this third pyramid, and this face on the bottom is P3. The triangles here are the two bases of the original prism. How do the area of these bases compare? So what we know is the areas are congruent. The areas are congruent. And how do we know that? Well, we know that because the bases of a prism are congruent. Okay, now how do the heights compare? So these blue bases are congruent in the picture on top. Now, how do the heights compare? Well, I notice this first height is 4 units high. I notice this second height is also 4 units high. So how do we compare these? Well, the heights are equal. So the heights are equal. And if we look at this, what I want you to notice is this height here, although it sticks up, it looks a little bit higher than 4, is I want you to remember what happened here is that this height right here is 4 units, and the only reason it looks like it's higher than 4 is because it's going back into the computer screen a little bit. Okay, so I know the heights are equal because they're each the height of the prism. The height of the prism. Okay, lastly, how do the volumes of these compare? So how are the volumes going to compare? Well, the volumes are going to be equal. The volumes are equal because, now for our explanation, they have equal base area and equal heights. They have equal base area and equal heights. Perfect. Number 2 here. Using the pyramids that we built, and that's again in 5.2. So when we talk about the pyramids we built, this is in 5.12 rather. Okay, using the pyramids, think of the gray shaded areas as the bases of the pyramids. These are formed by slicing one of the prism's rectangular faces down its diagonal. How do the areas compare. So if we think about that, what we're doing, what we're asked to do here is think about one of the shaded areas, right? And we're going to slice this down the diagonal. Now, if this is a rectangle, remember that opposite sides are congruent, right? So what we're going to do here is we're going to create the areas when we slice this. The areas will be congruent. And how do we know that? We know that because the triangles created are congruent by, now let's remember, side, side, side. Side, 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 congruent. So I've created two congruent triangles by side, side, side congruence. Okay, the heights of pyramids P2 and P3 are equal because when assembled into the prism, the height lines coincide along the length of the prism. How then do the volumes of these pyramids compare? Well, again, the volumes are congruent because they have let's make that neater. They have equal area and equal height. Now, based on these answers, how do the volumes of each pyramid compare to the volume of the prism? So now what we're doing is we're looking at the volume of each one of these pyramids and comparing it to the volume of this prism. And as we can see, each pyramid is 1/3 the volume of the prism. How could we use this information to find the volume of one of the pyramids? Well, if I know that the volume of a prism is equal to the base area times the height, and I know that each pyramid is 1/3 that, then the volume of a pyramid is equal to 1/3 the area of the base times the height, or we can write it as the area of the base times the height divided by 3. So that's how we can find the volume of a pyramid.